everyone. So far we have done Newton's laws and the way they can be applied to point masses. So F is equal to ma or F is equal to m d2r by dt2. We did this for a point mass. If it is having a mass m and a position vector r, then its acceleration will be d2r by dt2, and this is how the second law can be written. Now, instead of having point mass, if we have an extended body, let me take a rod, a bar. Now it is made up of a large number of smaller particles, and if I take weight, then each point weight is acting downward. Innumerable point masses are there and the weight is acting downward. For each point mass it is downward. And if there is any other force, I have to apply this. So I have to apply this on each point mass, and then I may find out what is the net force, what is the net acceleration of the body. This is one of the approach. Another one is, we can simplify this task of applying this law to this body. Let's take an example. This duster, it's again made up of a large number of particles just like this, and if I apply a force on a particular point, I can balance it. What does it mean now? This is balanced. So the force is acting at different points, but I can balance it by applying a force equal to the total weight of this object at just one point. So I mean, it is equivalent to this one. So at this, a downward force is acting, and if I apply a force in upward direction at that point, which is equal to the total weight of the body, this body is balanced, so net force becomes 0. So it means I can assume that the total mass of the body is acting at this point. This is called the center of mass. So center of mass is a point, an imaginary point, where all mass of the body can be supposed to be concentrated. So it's a point basically which can ease our task. It can make the application of these laws very simple. So center of mass, a point where all mass of the body can be supposed to act. Though it is also possible that there is no mass at that point, but even then the center of mass is at that point. For example, if I take a ring, its center of mass is at this point, but actually there is no mass at that point. Same way is sphere, hollow sphere, spherical shell. So even in that case, actually all those bodies which are symmetrical, the geometrical center will be the center of mass. So center of mass will be at the geometrical center if the body is symmetrical. If it is not, let me take another example, that there is a rod and half of it is made up of cardboard, another half is made up of metal. Let this be metal and this be cardboard or just wood. Then I cannot balance this at the center. It will be somewhere here. So center of mass will be in this. Center of mass, I can add something more to the definition that I told you. It's a point where all mass of the body is supposed to be concentrated. It's a kind of average position of all the particles of the body. Weighted average. It means the particle which is heavy contributes more. So center of mass will be towards the region which is heavier. So it will be here somewhere. Same way, if the mass distribution is not uniform, it will be towards the region which is heavier. If the mass distribution is uniform, then it will coincide with the geometrical center. And in order to find out center of mass of any object, we can hang it from different points. Suppose I want the center of mass of this object. So I can hang it here, then from here, and just go on drawing the vertical lines. That point from where all these lines will pass will be the center of mass. This is the way we can find out the center of mass. So it's a point where all mass of the body is supposed to be concentrated, a kind of average position. Let me take another example. This is a pen. Suppose I throw this like this, and I ask you which type of motion does it describe? Well, immediately it's a parabolic motion. It is a projectile and it follows it. But if I ask you the path described by individual particles of which this pen is made up of, suppose I say, what is the motion of the tip? So maybe sometimes the tip is here, then another moment it may be like this, then it may be like this. So maybe the tip is following this kind of motion. So it's not strictly speaking parabolic. But even then something describes the parabolic motion. Again, that is the center of mass. Right? So now let us find out how to calculate it mathematically for a given body. And I will start with the simplest case where we have just 2 point masses with position vectors r1, r2, m1, m2. So it is a m1 and m2. So this is the body. A body consists of just 2 point masses. The simplest one, in fact, if I take it, it is made up of a large number of particles, not just 2. But we will generalize the result after that. Okay, so now this I can apply Newton's law like this. Some force is acting on first, so F is m1 d2 r1 by dt2. Same way that some force is acting on m2, so F is equal to m2 d2 r by dt2. I can write it F1, F2. Okay, now I have to describe the motion of this complete body. So I have to add up. What is the total force acting? F1 plus F2 is m1 mass is constant. I can take it inside the integral sign. It can be written like this. Or it can further be simplified when I take this quantity as common and this becomes right. First, second, total, I add it up. But I want something of this form. Force is equal to mass into acceleration. Okay, this can be written in that form. Let me multiply and divide it by this term. It doesn't make any difference. If I have any quantity, say x, I multiply it by 10 and divide by 10, so it still remains x. It doesn't make any difference. So m1 r1, m2 r2 upon m1 plus m2. Force on first particle, force on second particle, then I have added it. Now this term has dimensions of length. So let me write R. This is the total mass. M d2R by dt. Now let us work out on this term. F1 is the force on first particle. It can be made up of some external component on one plus force due to M1. If some force is acting onto M1, how many types of forces possible? Either it is to be exerted by the other particle, or it may be some external force. The force due to this may be the gravitational force, maybe some other force, electrostatic force, or some other type of force also. Okay. Same way, force on 2, maybe nuclear force also. F2 external plus F2 on 1. It may be due to 1. So what will be F1 plus F2? F1 external, F2 external plus F12 plus F21. Newton's third law says that force on 1 due to 2 is always on force equal to force on 2 due to 1. So this cancels out, and this I can write just F external. So okay, now here we can write what does this signify. Now see this equation. This is again of the same form. Force is equal to mass into acceleration. Mass is total mass. Acceleration of a point described by this m1 r1 plus m2 r2 upon m1 plus m2, and this is external force. So it means when we are taking this system which is consist of m1 and m2, I can still apply the same law, F is equal to ma, provided I replace m by total mass, F external only, not internal, not the mutual force between the two, and the acceleration of a point described by this. This is the center of mass. So it means we can assume that this mass m1 plus m2 is at this point, and all the external forces are acting on this point only. This is the center of mass of two particle system. So we got R is m1 r1 plus m2 r2 upon m1 plus m2. This is how we can find out the center of mass for two particle system. For multiple particles, m1 r1, I can generalize the result upon m1 plus m2 plus total mass, or I can simply write summation mRIA upon total mass. I varies from 1 to 1. So this is how we can find out the position of center of mass. If it is given in terms of x, y or z coordinates, we can write separately. So x coordinate will be this, then y coordinate will be this, and z coordinate will be this. If we are given in the vector form, we can write that too. If the distribution of mass is continuous, we don't have 1, 2, 3, 4. I have a rod with mass distribution uniform or non-uniform. Then we have to find out using integration method. If I consider a small section dm with position coordinate r, rdm, integration, it will be the sum of all rdm. So rdm divided by m. This will be the coordinate of the center of mass.